Okay, so we are going to start with 9 minus 5. Well, I bet you there's a whole bunch of you in here that are like, don't even need to use the number line for that. What is 9 minus 5? 4. Okay, let's just write that right away because, we're like, I already know that. I've known that for a long, long time. Well, how can we show that? Don't try and fill out this sheet right now. Stay with me, okay? How can we show what 9 subtract 5, looks like on the number line, okay? Anybody have any idea how that works? Taylor, what would you do?
Go to 9.
So you go to 9?
On the number line.
Okay.
And go back 5.
Okay, but to go to 9, where do we actually start at then?
0.
0, because I want us to see, so let's do it above. Let's not do it on the number line. Let's go above and let's put a point here at 0 and say, I'm going to go to 9 like Taylor just said. I'm going to put another point and I'm going to show that I was going to the right, wasn't I? So we were going in the positive direction to get to 9, so that's like our starting point. And then he says we're going to go back 5, so we're going to go above that 9 and we're going to put another point and we're going to say now I'm going to go back 5, so you have to count on the number line. By the way, what's the number line going by? 1s, 2s, 5s, 10s? It's going by 1, so every tick mark you're going back 1. So you go back 5 spaces, 5 numbers, so 5 tick lines. You end up at positive 4. 1, 2, 3, 4, 5. We'll go down here and put a point on the number line at 4 to show our answer that we actually get. Now I want you to see something. Even though you have been subtracting numbers like this for a long, long time, why does it turn out to be 5 without actually using the number line? If we want to do it with an algorithm, what's really happening? We're going to change this to add the opposite. So 9 stays 9. The subtraction becomes addition. 5 is what's being subtracted. What's the opposite of 5? Negative 5. So what's happening is the same thing as we just showed on the number line. That 9 is positive. It's going in the positive direction. That 5 is negative. It's going in the negative direction. And what we have left over is right here. Notice what happens. We have 4 units of distance left over, and that 4 units of distance left over is in the positive territory, isn't it? It's to the right of 0. So that's why 9 take away 5 is 4. Because we go 9 in the positive direction, we come back 5 in the negative direction. We have 4 units of distance left, and that units of distance left is on the positive side of the number line. Okay? So let's do 5 minus 9 then. What is 5 minus 9? Do you know what that is? Negative 4. Okay, well let's check it out then. Let's do it on the number line and see what happens. So this time we will start at 0 like we always do. And what will we do? Go 5 to the right. So we'll go 5 units to the right, stop there, and we'll show an arrow on our distance of 5 there to show what direction we were going. We were going in the positive direction. Well, we're supposed to take 9 away from that. What would that mean? Starting at 5 now, what would we do? Go back 9. So now we would have to take, by the way, look at this number line. Is it going by 1s, 2s, 5s, 10s? Going by 1s, you always got to check that out. You always have to check that out. What is the scale on the number line? It's going by 1s. So we're going to go back 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And I'm going to end up right here. And I was going in the negative direction, right? I was going left. Now notice what happened. There's this overlap. These guys kind of cancel each other out, don't they? Remember us canceling? These kind of like cancel each other out. And what's left is this distance. How much distance is left here? 1, 2, 3, 4 units of distance. But notice where is it at? Is it on the positive side or the negative side of 0? It's on the negative side of 0. So you were right when you said negative 4. Let's change this to add the opposite. 5 what? Add the opposite. 5. No, we don't want to make 5 negative. Plus negative 9. It's gonna be really important that we understand how to do this, because when we keep getting more complicated, being able to change subtraction to add the opposite is gonna help us a lot, okay? So again, this shows that we're going a positive 5. This shows we're going a negative 9. And notice what happens. If we're just doing it without the number line, 9 has got more distance than 5 does. Negative 9, excuse me, has more distance than 5 does. 5 combined with that negative 9's distance, we take 5 units out of that 9, we have 4 left. But remember that distance was negative, that 9 that's left, so we have to have a negative 4. Okay, you go ahead and try that and do the next one, they're not numbered I guess, negative 3 plus 7. Show it on the number line. How do we take negative 3 and add 7 to it? Oh, by the way, we forgot to plot our point, what our answer was for this last one. We should put a point, what our answer is. So, show it, getting it on the number line. Remember, we start at 0, and for our first move, our first number starts at 0, and we work the direction that its sign is. What do you give for an answer? What's negative 3 plus 7?
4.
4. It's 4. Again, they had opposite signs, didn't they? We have negative 3, we have positive 7. What ends up happening? Is there any distance that cancels away? How much distance cancels away? Three units of distance cancels away, doesn't it? Right here. Right here, we have this 3 units of distance right here that cancels away. They overlap each other, they cancel each other out. And we have this distance right here. That's in what kind of territory? Positive or negative territory? Positive. The 7 has more distance, 7 is positive. That's why our answer ends up positive. So in reality, when we have two numbers with the same sign, and we're adding them together, we take the shorter distance away from the longer distance, and we say, what was the sign of the longer distance? Okay, this one, would we change this one to add the opposite? Would we change negative 3 plus 7 to add the opposite? What do you think? Why not, Blake? Because I agree with you, Blake. I want you to know that. I do agree with you, but why? Okay, why would we not change negative 3 plus 7 to add the opposite?
If you have the opposite, you'd be subtracting it purely.
Isn't it already an addition problem? It's already an addition problem. Are we going to change an addition problem to another addition problem? No. Are we going to change an addition problem to a subtraction problem? No. We're going to leave it alone. It's already an addition problem. We do not need to change it to an addition problem. But how about our next one? Is our next one an addition problem? No. So let's do the add the opposite thing first, before we even do our number line thing. What is negative 3, take away 7, written as an add the opposite problem?
3 plus negative 7.
Is this what I'm hearing? Is that what you said, Adam? Okay.
Negative.
Okay, so in other words, the first number does not change, does it? That negative 3 starts it. This subtraction is what gets changed to addition. And the opposite of 7 is what, Holly? Negative 7. So the subtraction changed to addition, the 7 changed to its opposite, it changed to negative 7. Okay, what do you predict the answer to this one should be?
Negative 10.
Negative 10. Why?
Because you had 7 and 3 is 10, and they're both negative, so it's a negative.
So 7 plus 3, Taylor is saying is 10. And since they're both negative, that means our 10 will be negative? You want it to be positive? A negative negative is a positive?
Depends.
When does it depend? Yeah, it depends on whether you're multiplying or you're adding, doesn't it? When you're multiplying, a negative negative is a positive. When you're adding, a negative plus another negative is a negative. And let's show how that happens. Okay, let's go do it then. Let's start at 0, and we're supposed to go to a -3. So in other words, we're supposed to go left 3. And then it says we're supposed to add a -7, which is going which direction? To the negative, and we're going left again. So now we're starting at -3, and we're going back 1, 2, 3, 4, 5, 6, 7 units. And look at where we end up. At -10. When we're adding negatives, 2 negatives added together stay negative. It becomes negative. You add their distances together. 3 units of distance, like Taylor said, plus 7 units of distance is 10. But make that 10 negative because they were both negative. You were going to the left twice. You can't end up in positive territory when you're heading left twice. Okay? Okay, how about that next one? -2 plus, let me put a point on our number line there. Okay. -2 plus 8. Do we need to change that to an add the opposite problem? Why not? It's already addition. Don't mess with it. Leave it alone. It's already addition. Now, if we are not going to do this on the number line, tell me what would we do? Don't even do the number line. Stop. Do the algorithm. Here's what the algorithm says. Add their distances or subtract their distances or something. What are you going to do? You're going to take 8 minus 2. You're going to take 8 has a distance of 8 units. -2 has a distance of 2 units. So you're going to take 8 take away 2 because they have different signs. And what's 8 take away 2? 6. And then you're going to give that 6 the sign of the number with the longer distance. So which one has longer distance? 8 does, and 8 is positive, so that means our answer should turn out to be 6, shouldn't it? So let's see if it does. Okay, let's go on now. Go to your number line and start at 0 and go back to,
-2.
and then you're going to go what direction for the 8?
Right.
To the right, you're going to go.
Positive.
The number line is going by 1, so we can go 8 tick marks over 8. And we're going in that direction. And sure enough, look at what happened. You guys said, the algorithm says subtract 2 because 2 units cancel out. They overlap. So those 2 units, that's why we subtract 8, the longer distance, take away the shorter distance because we know so that's going to cancel out. And then we count up how many units of distance do we have left. We have 6 units of distance on the positive side of 0. So we say our sum is 6. Okay. Blake.
Did you not need to read the lines up on the other one? Probably.
Which one? This -3 plus -7? What do you mean do the lines?
Or you just wrote down all the.
Oh, I didn't write the answer? Here? Maybe that's.
Um,
Oh, it's right here. You see it? Is that what you're talking about?
No, never mind.
Oh, is there anything that cancels out in that one?
Okay, that's what I was.
Oh yeah, there's nothing that cancels out, right? We're adding negative distance plus more negative distance. There's no canceling. That's why we add their distances together instead of subtracting their distances. So they have the same sign. Okay. How about this last one? Should we change it to an add the opposite problem? Yeah, it's not addition, it's subtraction. It says -2, subtract 8. We will change those to add the opposite. So, in fact, in your homework, on the back side of your homework, they're going to have changed all of them to an addition problem. So, Leah, what would be -2 minus 8 written as an addition problem?
I can't think right now.
Turn around on your desk and stop messing with them on the table and try real hard to think with me. Anybody want to help out? Andrea, you got it?
-2 plus
-2 + -8. The subtraction becomes the addition. The opposite of negative or +8 is -8. So we're adding two negatives. What happens when you add two negatives? Will the answer be negative or be positive?
Negative.
Has to be negative. You're going in the negative direction twice, aren't you? You gotta end up in negative territory. So we know that it's gonna be negative, and then we have 2 units of distance plus 8 more units of distance. What will that be? So we should end up at -10 on the number line when we do this one. So we start at 0, go back 2. We start at -2, go back 8, 3, 4, 5, 6, 7, 8 units. And sure enough, we end up at -10. So take a look at that paper right now. Every time, after it was rewritten as an addition problem, every time that you had a problem where both of them had the same sign in the addition problem, they had the same sign in the addition problem, what was happening? Were we going the same direction, or were we going opposite directions? What was going on? Look on your paper. When both numbers had the same sign, were we going the same direction both times, or were we going opposite directions?
Same.
So here's an example right here, this one. Were we going same direction or opposite directions? Same. Where's another one that we were going, we had, oh, here we got a negative and a positive. They don't have the same sign. Here we have two negatives. Were we going in the same direction both times? Yes, we were. What happened? Do we have any other times that they had the same sign? No. Now all the rest of them have, one of them's positive, the other one's negative. And I want you to take note that every single one of those times there was an overlap, something that we could cancel out. And we did if we're going to do this without the number line, we would do a subtraction problem, wouldn't we? Of their distances. So that's what we really did, is take 9 units of distance. When you back up 5, those 5 cancel out, so 9 take away 5 is 4. But then you look at it and you say which distance is longer. That's the sign of my answer. You need to be able to process this, not count on your calculator to be the one doing the processing. You need to be able to add and subtract. We're going to always add because we're going to change subtraction to add the opposite. You need to be able to add with these integers, with them either having the same sign or having opposite signs, and be able to get the answer and feel confident about it, and not even have to say, can I just check with my calculator? And you should feel so confident about it that you're like, I don't even need to check with it. It should make sense. Anybody have anything that's still unclear to them on this? Okay, then we're going to start the homework.